Hello, I'm Chris Athanas. I'm a KMP developer. And today we're going to continue our series of how to program from the ground up. Oh yeah, tech support called. They got the tool. They got the part. The guy's out sick. So I have to wait another. They said another week, back on Tuesday. Okay, so we'll get that done soon enough. And today we're talking about polymorphism. Ooh, big idea. Ooh, it must be something so different than everything we've already been doing. Nope. Same stuff. Same stuff. When I first heard this word, I was like, what are you guys talking about? And it's the same thing. A method that can be called an object is have a method that can be called an object, and the method will behave differently based on the class of the object. Same thing as interface, same as a bootstrap class, same as a list-off we've already seen again. This is another example of an exceedingly obvious idea with a ridiculously overcomplicated name. Yet another overcomplicated name for a very basic, exceedingly simple idea. This is how I feel about it. Let's go back to our the war games. Let's listen to what Ben. And he's talking about backdoors here, which is like a hard-coded password you put into a program that nobody can figure out. Like touching different parts of the screen in a certain sequence will let you get in. Nobody ever does that though. No. And this is how they made this polymorphism sound.
You're not supposed to see any of that stuff. That system probably contains some new data encryption algorithm.
Ooh, what is that? Ooh.
You'll never get in there.
Hey, I don't believe that any system is totally secure. I bet you Jim could get in.
Yeah, I bet you couldn't.
I bet you he could.
Well, you'll never get in through the frontline security, but you might look for a back door.
Ooh, a back door. Ooh, what's a back door? It gets a little sexual here, so if you have young people around, you may want to let them leave the room.
I can't believe it, Jim. That girl's standing over there listening and you're telling her about our back doors?
Potato Head. Mr. Potato Head, back doors are not secrets.
Polymorphism is not a secret.
Yeah, but Jim, you're giving away all our best tricks.
They're not tricks.
What's backdoor?
Well, whenever I design a system, I always put in a simple password that only I know about. That way, whenever I want to get back in, I can bypass whatever security they've added on. That's
Nice.
basic.
So he's a cop programmer, so he can, just make it static and make it public and mutably change it. So, all right, let's keep going here. Quick goofing off. All right, Liskov. It's associated with the Liskov principle. Same idea, same exact idea. That a subclass should be replaceable with its superclass. Anywhere that accepts the superclass, you can accept the subclass. Ooh. People made such a big deal about this, and honestly, it made it confusing because they made such a big deal about it. And I don't know exactly 100% why, but it has to do with this overuse of terms. Seems to be a bit of a de-swinging contest around these words among the Aspiatal crowd. And please, someone tell them when they're being dicks. They're being dicks. When they just suggest a fancy new word for something super basic, please tell them to calm down. Do we really need a new word for this? Anyway, so we have already discussed the Liskov principle example, and you can just go through here. This is it. This is all you need to know. This is all you need to know. And if you don't understand the code, you have to go in here in the code and mess with it. So you go change it from an open class to a closed class and see what happens if you inherit from a different interface. You can add another interface on here, like shape 2. We'll see how that happens versus trying to make it interface like come from another class. Just mess with it. That's the only way you're going to learn this stuff. You will never be able to understand it fully. How simple and direct and like straightforward it is from somebody talking about it. So you got to go in there and run the program. Hit the arrow button and mess with it and look at the compiler errors. They're so good these days. Look, it says right here, circles.add. You can't add it because look, it's a type mismatch. It's requiring a circle right here. This requires a circle because there's only types of circles. And saying, look, I only found a rectangle. And so the messages are so good now. So yeah, we don't. Moving on to controlled visibility of variables and methods. So this whole private public thing. All it's trying to do is instead of having everybody be globally mutable, everyone globally accessible, you can see every global variable like you did in C. Now you have to say, oh, I want those to be private. Instead of being publicly seeable, everything can see it, I only want to be private so they're only in this class. And I have an example here. So it's basically making a variable private means it can be only accessed by the methods of the class and not by any other class. When you make them, so use of private and protect and public control the visibility of the methods. And the private, so next, I might delete this one. I might have to delete this one here. Make a variable protected means only the subclass can see it. It gets to see it too, but nobody outside. Whoa, it's protected, it's different, it's so crazy. So the private, so if you subclass something that's private, the subclass ain't gonna see it. But if it's protected, it gets to see it. Oh wow, it's just really amazing. Okay, I mean, you could make all your variables in these programs completely public, and it would still run fine. The compiler doesn't care. It's for us. It's for us to know: is this only for this class? Is this variable only for this class, or is there somebody outside using it, making it public? That's why it became important, because they wanted this direct access, this cop level access. This becomes less important when you're just accessing everything through methods, and everything's inside. You can't get. You have to ask some. You have to ask somebody to get a variable, and that was the whole idea with the setters and getters. That's what makes it object oriented. No, just by calling a function just to get the variable back, or calling functions just to set it. That's the same thing as setting it, guys. You're not. The cop guys just have fought this every step of the way. For, I'd say 20-30% for good reasons, because they want to get that extra 10% out of the metal. But the rest of them are just like copying along, just cargo culting the thing. So it's like, God, stop. So this example is very long. It looks very long, right? But it's not. So all I've done here is each one of these little arrows is just a different comment. And I want you to go through and look at what happens when you change these things from public to private to public to private. And like inside here, protected, make them public, and to see what you're allowed to see down here in this other class. Like here, let me put this up here, leave this up here. You can see down here. So how it runs through stuff like, okay, so if it's a type, you're gonna have to go through and look at this. I'm not gonna walk through this code. It's too obvious to even speak about. So go in here and you can actually like uncomment these things. It'll tell you like the problem, like unresolved reference. It doesn't know what the last updated by name. Okay, it can't see that. It can't see that. So that's what's going on there. So that's all that is. It's just programmers trying to be like, okay, trying to reduce the amount of mutable shared state. That's all this is about. This is all this is about. Once it goes into like pure OOP, everything's enclosed. You can't get direct access to anything. You have to go through a function, a method of the class. So that's the whole big idea. Yeah. So next up, we're gonna be getting into multiple inheritance. This is gonna be a short one. So this one right here, I just did a short one. And multiple inheritance is the next one. So I'm Chris. I hope you've enjoyed my rant so far, and we're getting to the end of the COP programming, and we're gonna move on to something a little more interesting. Well, this is all useful. We all build. These are all tools to build on each other, but some ideas were just like, we had to live with them for a long time and deal with, and still have to do to this day. Some of these bad ideas, and some of their good reasons. Some people just don't know that there's another way to do this stuff. So, all right, give me a like and subscribe. Thanks.